All right, good morning, Algebra 2 class. Let's go ahead and get started. We're going to continue on with graphing parabolas in vertex form. So last week we were noticing patterns about how vertex form affects our parabola. So today we're actually going to be graphing parabolas out. So the whole worksheet today is dedicated to graphing parabolas, guys. So our objective, guys, we will be able to graph parabolas in vertex form by noticing its patterns. We already noticed its pattern, or we already got our patterns down last week. How H affects the graph, how K affects the graph, how A affects the graph. So we're going to go ahead and use those to be able to actually graph out some parabolas in vertex form. So let's go ahead and get started, guys. All right, so just a quick reminder, guys, this is what we're building up to, and this is what we're going to be working with today. This is our full vertex form. This is y equals a times x minus h squared plus k. And a reminder, guys, or let's go ahead and get into that now. All right, so let's see how the k value affects our graph, guys. So the k value is vertical shifts. It moves it up or down. So if our positive k value if our k value is positive, our parabola moves up, but not only our parabola moves up, our vertex moves up as well. And on the opposite side, if our k value is negative, our parabola moves down, our parent function moves down, and our vertex moves down, guys. So let's go ahead and take a look at how that works again here on Desmos. So as you guys can see, in our red, we have our parent function here, and we have it in vertex form. I have these sliders A, H, and K here. That's not important. That's just to show you guys how it affects the graph. So as you guys can see here, K, if our K is positive, it moves our graph positive as well. Or I'm sorry, it moves our graph up. So one thing I do want to note, guys, is keep an eye on your vertex. Remember, your vertex is here, the very middle point of your parabola. So our parent function, our vertex is 0, 0. But when we move our graph up, our vertex moves up as well, and the value of our vertex changes as well. If we move it down, same thing. Our graph moves down, and so does our vertex. I'm going to set this back to 0. That way we can go back to our presentation. But just a reminder, guys, that to keep an eye on that on your vertex point. All right, now H, guys. H is our horizontal shifts. Positive H values move the parabola to the left and your vertex to the left. Negative H values move our parabola and vertex to the right. So keep that in mind, guys. I know it seems a little flipped, but positive H values move it to the left, and negative H values move it to the right. So let's go check that out right now. We have our H. Negative is going to move it to the right. And take a look at our vertex as well. Our vertex obviously is moving as well, guys. And when it's positive, it moves to the left. So one thing to note, guys, is again just to be able to identify where your vertex is going, because that's going to be a key part of how we're going to graph out our parabola. So now let's go ahead and focus on A, how A affects our parabola. This is what we finished up with last week, and there was real 4 main things that I wanted you guys to get from it. The first one, guys, is when A is greater than 1. When A is greater than 1, it makes our graph more narrow and it opens up. When our A is between 0 and 1, this means fractions and decimals. When our A is between 0 and 1, our graph gets wider. So let me go ahead and show you that here. So we have our A value. Our A is equal to 1. So when our A becomes greater than 1, like to 2, 4, and so on, our graph becomes more narrow. But now if it's between 0 and 1, our graph starts to widen out. Now take notice what happens when our when our a value becomes 0. Just becomes a straight line. The reason why that happens is because when our a value is 0, it basically cancels out the rest of the equation to just being 0. So that would be a linear function, because that squared would go away. But we're not focused on when a is 0. We're actually focused on when a is not 0. So again, guys, when a is greater than 1, it makes it more narrow, but it opens up still. When a is between 0 and 1, it makes it more wide and it opens up. All right, so now let's go ahead and get into the negative a values. So when our a is less than -1, so like -2, -3, -4, and so on, it makes our graph more narrow again, but now it opens down because of that negative sign. And when our graph is between, or when our a value is between 0 and -1, our graph opens up and becomes more wide, but again, it still opens down because it's going to be a negative. So let's go ahead and take a look at that. Our a value when it's -1 is basically our parent function just flipped over the x-axis. But now when we go less than 1, -2, -3, and so on, our graph gets more narrow and narrow and narrow. But now when we're between -1 and 0 again, it starts to widen out. Like all the way to when we hit the point 0, which it just flattens out. But again, we're not focused on when a is 0, we're focused on other numbers. So that's how a affects the graph, guys. It's the way to determine if it opens up or opens down, and it's the way to determine if it gets more narrow or more wide. So again, guys, if our a value is positive, it's going to open up. If our a value is negative, it's going to open down. So let's go ahead and get into an example on what we're going to be doing today, guys. So we're going to be graphing out these parabolas that are in vertex form. So these are a couple things that I do want you to do. So we're given our example. So the first quadratic, or the first parabola that we're given, is y equals x minus 5 squared minus 4. So guys, take notice that there's no actual number out for a, but when that happens, a is just +1. Or if there's just a negative sign out there, a is -1. So anytime there's no number on the outside, our a is just either negative or +1, depending on the sign that's outside. In this case, we don't have a negative, so we can assume that our a value is going to be 1. So our graph ain't gonna be more narrow or more wide. It's gonna be the same as our parent function. We're just moving it around. So the first thing that I want you guys to be able to identify, guys, is your vertex. And your vertex specifically relates to your h and your k value. So for your vertex, the point for your x, the point of x, you're going to take a look at your h and you're going to flip the sign. So we have -5 in here, so our x, our point for x is going to be +5. And now for our point for y, guys, for our vertex, you're just copying your k. So since we have -4, we're going to bring it on straight down, and it's going to be -4. So again, guys, just a recap, to find our point for our vertex, our x value is going to be our h flipped. So we had -5, it's +5. And then now for our y value, it's just copied. Same value. We have -4, so our y value is -4. identifying the axis of symmetry, guys. So the axis of symmetry is just the your x value. So remember our x value of our vertex was positive 5. So our axis of symmetry would be x equals 5. And that's the way you're going to write it, guys. It's going to be x equals whatever your x value is on your vertex. So for example, in this case, our vertex, our x value is 5, so our axis of symmetry is x equals 5. If our x value was negative 7, then our axis of symmetry would just be x equals negative 7. All right, so now we're going to go ahead and sketch the graph, guys. So the first thing that I'm going to want you guys to do is plot your vertex, guys. So our vertex is positive 5, negative 4. So we're going to find ourselves positive 5, 1, 2, 3, 4, 5, and go down negative 4, 1, 2, 3, 4. So our vertex will be here. And now notice, guys, again, like I shared, our a value is there's no number outside, so we can assume that it's just going to be positive 1. So we know it's going to open up. And it's just going to be basically the same scale as our parent function. So the three things that I'm looking for, guys, is one is your graph, making sure it's graphed out. Remember, guys, if your a is greater than 1, make sure your graph is more narrow. If it's between 0 and 1, like a fraction, make sure it's more wide. So make sure you're graphing this out. And then I'm also looking for your vertex. And then also another thing that I want you to identify is your axis of symmetry. And the way you can identify that is just by drawing a dashed line through your vertex all the way up like so. So on your worksheet, guys, on the graph, I should see this. I should see the vertex plotted out, the graph sketched out, and your axis of symmetry dashed out. But also on the side, I want you guys to be able to label these three things. Identify your vertex, identify the axis of symmetry, and tell me if it opens up or opens down. So I'm looking for a total of 3 things. These 3 on the side of the graph, and then these 3 on the actual graph, guys. All right, so you guys actually have a worksheet to do. You guys have about 12 questions to do. It's all going through what we just did just now. If you guys have any questions, feel free to ask me. Again, guys, make sure you guys are watching the video and accessing the material because I am keeping my eye on that. All right, so I hope you guys have a good rest of your day, and I look forward to seeing you guys for day 2.